Okay, so we're going to go over the homework that is assigned for this page 41. Well, it depends on which class you have, but it's this page that looks like this table with all these different numbers. So, but I'm going to start with the previous page, either 40 or 39 for your class, but the page looks like this. So here the booklet says the numbers in here are real. So we're talking about real numbers, like literally real numbers. For most of our classes, we did write something here. Imaginary numbers are not real. So there are such numbers, and numbers like square root of a negative number is not real, and we call them I. I stands for imaginary. But you're probably not going to learn about that until later in high school, if that. So I just wanted you to know that that these types of numbers do exist. However, we are going to look at the difference between irrational or rational real numbers and irrational numbers. So these are both real, these categories are real numbers. Remember, this says every number in here is real. So all these are real numbers, but all real numbers can be categorized into two major categories. So rational and irrational. We're going to start with rational, because if it's not rational, then you'll know it's automatically irrational. Integers. Okay, so we talked about this today. Those are the negative and positive numbers, like negative 5, negative 4, negative 3, negative 2, negative 1, and 0 as well, and then 1, 2, and so on. No fractions, no decimals are integers, but any of these are considered rational. Perfect square root of perfect squares, like square root of 4, or square root of 9, or square root of 121, and negative versions as well. Those are all rational. Any fraction where you have an integer divided by an integer that's not 0. So this would not be rational, okay? The 0 cannot be on the bottom, but this is rational because 0 divided by 5 is 0, okay? Any other integers, like maybe negative 2 over 7, that's a rational number, because the word ratio means the ratio of two integers. So now, if you're dealing with decimals, if you have like a repeating decimal, or it terminates, meaning like it ends, like 0.5, that terminates. It doesn't repeat, it doesn't keep going, okay? Or 0.788, it stops. There's no dot, dot, dot after it. Whereas over here, an irrational number would keep on going, like 0.788, and then dot, dot, dot means we don't know if there's a repeating pattern or not. So this will make it irrational, okay? And it's non-terminating. Non-repeating as well. So it has to be both. Okay, non-repeating and non-terminating. Whereas over here, you can have, for rational, it's repeating or terminating. Okay, so I know that's a lot, and we'll talk about this in class tomorrow, but I wanted to see if you guys can try your best to see if it's rational or irrational. Irrational are never integers. They are never square roots of perfect squares, like, for example, square root of a 5, okay? That's not a perfect square, so this is irrational. Or if you have a fraction that involves square roots of non-perfect squares, like this may be rational, but that's not rational, so together it's irrational, okay? I know that's a lot. You can review that this part of the video just to kind of go back and listen to it and then kind of let it sit and marinate. But here you will see that there are many numbers, and these are all real numbers, okay? All real numbers. None of these are imaginary. But which one's rational and irrational? So here, this is a square root of a perfect square. So if you go over here, perfect square, that's rational, because this comes out to be 5 or negative 5. So this is rational. This right here, this is 123 is not a perfect square. So if you were to take the square root of it, you're going to get this non-repeating, non-terminating decimal. So negative or positive, that doesn't make a difference. So this is irrational. Oh, wow. Okay, let's change this to a 1. Now we know that 121 is a perfect square. If you take the square root of that, that's 11. Negative 11, hey, that's rational. So this is 11. This is 3. That's rational. The square root of 2/3, okay, this 2/3, when you take the square root of it, it's not going to be, this is not a perfect square. So this is irrational. Hey, a fraction, an integer and an integer, that a ratio of integers, this is rational. A ratio of two integers, this is rational, okay? Here we have a 1 0, then a 1 0 0, and then a 1 0 0 0. It kind of looks like a pattern, but we don't know what's going to happen next. And this dot 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 lets us know that it's non-terminating and it's non-repeating. We don't know what's repeating. So there's no repeating bar. So this is going to be irrational. Now this 10 is not a perfect square. If you take the square root of it, it's not going to give you an integer. So this is irrational. This is rational because 25 is a perfect square. When you take the square root of it, it's equal to -5. So it's going to be rational. This decimal here, if you go back to a rational number, if you have a decimal, if it's repeating or terminating, it's rational. So it terminates. It doesn't keep going. Okay? So it is rational. 6, that's an integer. So that's rational. This is rational. This is rational. -10 divided by 5, that's rational. This is an integer, rational. Pi, definitely irrational. Has a repeating decimal, so that's rational. Okay. And this is also a repeating decimal, that's rational. This is a terminating decimal, doesn't keep going, and so that's rational. This is also terminating, so it's rational. This is an integer, a really big, high integer, so that's rational. Now this almost looks like pi. In fact, it's the 1, 2, 3, 4, 5 first digits of pi, but this terminates. It doesn't show a dot, dot, dot. It doesn't show that it's going to keep going and we don't know the pattern. So this is actually rational because this is a rational version of pi. They basically cut off the rest of the digits. This is also looks like pi, the shortened version. It is, so since all the other digits are not there, it's rational. This is a decimal that terminates, so that's rational. This is a negative integer, that's rational. This is a negative decimal that terminates, that's rational. This is a negative fraction of 2 integers, that's rational. This is rational because the decimal terminates. This is a negative fraction of 2 integers, that's rational. 1's irrational. And here, what's interesting is that you can actually rewrite this as square root of 4 over square root of 9, and square root of 4 is 2, okay? And square root of 9 is 3. This is actually rational because 2 and 3 are both integers. Here, you have a square root of a perfect square, so that's square root of 100 is 10, and -10, that's fine, it's rational. Square root of 0 is 0, that's rational. Square root of 48, hey, 48's not a perfect square. So if you put that in your, calculator, it's not going to give you an integer. It's going to be a long, non-repeating, non-terminating decimal, so this is irrational.